Hi, I'm Dave Karow, Continuous Delivery Evangelist at Split, and I wanted to take just a few minutes today to cover some material that's really relevant given all the conversations I've been hearing lately about business continuity planning. In other words, what do we do now and how do we reduce risk going forward in these uncertain times? It turns out that the tools for being a modern software organization, which have been evolving in the last decade or so, are exactly the tools you need to cope with this business continuity planning. So I'd like to lead us through a conversation of rethinking our release process to take advantage of the work that's been done to accelerate how we deliver value to the market with less stress, with less chaos, and with the coordination that can support distributed workforce like we have now. Every release is a balancing act. We need to balance speed and quality and risk. Big releases are company-wide events, right? You've got product and engineering that are designing and building something. You've got marketing that's creating advertising and press releases. Operations has to stand up services. Sales and customer support need to be ready to take it live in terms of supporting the users. And maybe if you're lucky, the human resources team is creating swag to celebrate with, right? There's a lot of people coordinating a lot of things. So release success depends on coordination, really two kinds of coordination. Discipline coordination, which is between the different teams that are working on different aspects of release, and service coordination, which is releases are typically complex. We're working with multi-tiered systems with service-oriented architectures. We're working with modern software where there's a lot of things that have to fit together right at the right time, right? So how can we make releases less risky and less stressful? So here's what I'd like to share. First, I want to talk about mindset, some fundamental principles that teams that are able to tackle uncertain environments and uncertain times and actually win in times of uncertainty all have in common. Then we'll actually go into the release strategies themselves. We'll talk about data science as a way to separate the noise from the signal when you're actually doing releases. And then finally, how can we automate all this? How can we make this sustainable by automating this kind of change at scale with a platform? So let's talk about mindset. So the first mindset is choose go over no. Teams that are able to move a lot of change quickly focus on flow and localizing decisions. And friction and centralized decisions are kind of pulled out of the process as much as possible because those things are not inherently scalable to move a lot of people fast. And I love this quote from Jez Humble. He was talking about continuous delivery and he said, what you're fundamentally doing is reducing the transaction cost of pushing changes. And cost could be money, cost could be time and energy of people. It's the friction, the amount of work it takes to actually push some sort of change through. And there's a lot of really amazing advice from Jez in this blog post on the Split blog if you want to have another look after the webinar. The second mindset is choose data or behavior over opinions, right? And I don't know if you've heard of the hippo. The hippo is the highest paid person's opinion. And when I give talks, I often try to point out that, the highest paid person doesn't necessarily know what technical decision to make or exactly where to take the product, but they're under pressure to say something. And how much more productive is it to actually run an experiment and have data to feed the hippo with so that they can agree with you in the direction you go? It sort of reverses the flow of things. And this book, Trustworthy Online Controlled Experiments by Ron Kohavi and Diane Tang and Yazoo is a great book that talks about the cultural and the technical aspects of actually having hard data to make decisions on when you're pushing your releases through and deciding where to go next. And then finally, choose experimentation over surveys. And I know you may be thinking, hey, we're talking about releases here. Why are we talking about experimentation and surveys? You're building these releases to have an impact. And so often we spend so many of our cycles doing something that we're just supposed to do without actually having a firm hypothesis for why we're doing it and a way to prove whether it actually achieves it. And so rather than do customer research and try to just ask people what they want and ask the executives what they want, the key is to have a way to gather your own data to prove what works and doesn't work. And this Alberto Savoia is a really smart guy, worked for Google. He's at Stanford, and he wrote a book called The Right It. And a couple of key concepts that you can kind of take away. If you can look at the book, it's got a lot of good stuff. But your own data, this is basically data you capture from your own customers using your own solution or your own approaches is vastly more valuable than data you get anywhere else. And then skin in the game is this idea that asking somebody what they want is of very little value, but actually watching somebody do what they do or having somebody really actually commit money to something, there's way more skin in the game when they take an action and especially when they spend money. So these are some mindset stuff that I wanted to kind of begin with, which is, choose go over no. You got to figure out a way to get out of people's way, but count on data, not just opinions, for what gets done and what gets done first and whether it succeeded, and then use experimentation over surveys to guide this process. Because what we're going to work towards in this talk is, how do I build kind of an automatic, self-perpetuating machine that gravitates towards what works and doesn't waste a lot of time on things that don't. So let's talk about release strategies. And our goal here is, how do we make this less risky and less stressful? And let's talk about an ideal release. In an ideal release, we would actually have our code where we think it's complete and we would deploy it, but we wouldn't expose it to any users. We would just put it on the production infrastructure and give it a last check with our own developers and testers, and maybe do some dogfooding internally. At this point, we've got our code where it needs to run. It's in the exact environment it needs to run, and no users have been exposed to it. And then we might want to do something called an error mitigation. How do I expose this code to a small number of users in order to identify bugs and crashes that we didn't find in our own testing? And this is a very small cohort that you're doing. And the idea is here, how do I just reduce the risk? And if I find a problem here, I can roll back with very little egg on the face. No freaking out, no war rooms, no apologies, hopefully not too much Twitter traffic about this, right? So ideally, you want to go from this sort of deploy and test in production to this error mitigation phase. And then I want to be able to measure, is the release that I'm rolling out actually doing what I intended it to? I did it for a reason. There's either a system change in terms of how the system's supposed to perform, or there's user behavior change of how users are going to behave. And I want to be able to watch that, right? And the most powerful way to watch that is actually to have half your users in the new experience and half your users not in the new experience. But there are other formulas you can use. But think about it. This is called maximum power ramp, which is that I've got the maximum number of people going through both the old and the new experience, and I'm able to measure the impact. So how do I do that? How do I make that part of my release process? And then the last steps are scale mitigation. So once I've decided that it's having the impact I want and I'm not going to roll it back, I want to actually make sure that my infrastructure can handle it at 100% scale. And so I might stop at 70 or 80 or 90% and go through a peak period, a peak traffic period, to make sure that I don't have any scaling issues on this new thing I've done. And maybe you're pushing a small release, or you're pushing a big release, but you never know what's going to actually cause a major bottleneck, right? So, and then finally, I'm released, and then release kind of a complete rollout. Now, you might think, release, there's that word. Notice that this ideal release process actually breaks this release away from a big bang, oh my God, here we go, to something that's gradual, very measured, and learns the important lessons with the least damage to your market, to your customers, each step along the way, right? Now, the way we do this is with progressive delivery. And progressive delivery can come in different flavors. You may have heard of canary releases. You may have heard of blue-green deployments. There are various ways to gradually push traffic through a new version, but the most powerful way, and the way that I believe in, is feature flags. And that's because with feature flags, we can control the exposure at a user level, and we can observe the impact at a user level. So for those of you that aren't familiar with feature flags, it lets you separate deployment from release. You can deploy code whenever you want to, but it actually doesn't begin to get executed until you flip a feature flag and say, yes, let this user or that user come through this code, or all my users, or half my users, whatever. That's the release. The release is actually turning the feature on using a feature flag. So we separate the physical movement of the software into the production environment from the people going through that code. And this is done through a simple if-else statement. What's happening is that somewhere in your code, you put a function call that says, hey, should I run through this code path or not? And you pass the context to that if-then statement. And what's going on there is there's a function call to a feature flag layer that knows whether the current user or the current execution context should go through this path, right? And so that way, the simple little concept of putting a conditional statement in there and being able to remotely control it with logic is what makes a feature flag work. And there are flags that are just as simple as an on-off switch. There are flags that are a ramp, how do I slowly go from one level to another? And there are even flags where you would actually deliberately break the users into multiple cohorts and have multiple experiments going on at the same time. You may be trying a legacy back-end search algorithm and two new ones to see how users behave and how the system behaves in each of those seeing traffic. And then lastly, when you have feature flags, you've got what some people like to call a big red button, which is that instead of something goes wrong, instead of having to do a rollback or revert or roll forward, you literally just push a button and turn it off. Because the feature flag is in the code already, and because you can turn it off and people stop going through that code, there's no need to actually have a fire drill and a war room to figure out how do we get back to where we were, because you can literally just turn it off. So I covered kind of a simple, straightforward case there, really, which is I'm rolling out and I've got this thing that I'm rolling out and I want to go through various stages. But in modern software, we often have sort of dependent launches where there's multiple pieces. We've got the back end, we've got the front end, we've got various services. We want to do various kinds of testing. We may have a database migration. So what I want to do is cover briefly, before I move on to the other parts of my talk, just briefly cover some more complex scenarios and how feature flags make a really big difference, right? And the one I want to focus on really is that if you've got like a service or a database migration. So think about it. You've got an application that's making calls to a back end, right? That's your infrastructure. And how do we get from one version to another, right? Now, in a traditional migration, you'd have your starting point, and at that point, you might have to shut down the back-end systems that are using the infrastructure so that you could spin up a migration. You could load the new software, perform a migration, and then you would start the systems, have your front end point to the new infrastructure, and then there's this all-important step 4, which is to just hope it comes back up. And if you remember that the maintenance intervals and the Sunday night releases or whatever, where you'd be down for hopefully 2 or 4 hours or whatever and come back up, this is the sort of drama and lots of bad pizza and everything that people used to do. Well, so when you do that, you've got all these issues to deal with, right? There's downtime to release. There's downtime if you need to roll back. You're likely to be doing this migration at night or over a weekend, so it's not really great for quality of life. There's really limited testability because you're kind of doing this big bang release, and you've got to quickly do a sanity check and decide whether to move on or not. And if you do roll back, you lose transactions that happen during the initial rollout, right? So let's compare that to a migration using feature flags. Here we've got feature flags at the front end that are basically telling the front end which back end to hit, right? And so the first step really is to have those feature flags in place, right? Now the second step is to stand up the new back end, the new infrastructure, and enable what we call dual writes. Have the front end writing to both infrastructures, right? Then you can perform a data migration from the V1 data to the V2, at which point you've got all the data in V2, right? And then you do what's called a dark read. So you're still dependent on V1 for everything right now, and your users are still really only experiencing V1, but V2 actually in the background is being used with real live data, and you can actually perform those dark reads and validate that the system's behaving as it should. And then if that proves out okay, you can transition to just using the new V2 system, right? All using the feature flags to tell the front end, where should I be sending requests? What should I be looking for in the responses, right? So you're able to change that without a new deployment. You're literally just turning knobs in a way as you go through these steps. So let's compare that. So there's zero downtime when you go this route. You don't have to shut stuff down and install new things on those same servers. You can roll back without data loss because all that data was being captured in V1 in the first place, all the way up till the very end. And you can migrate when convenient. So you can do this during working hours when everybody is there. And the migration is tested with real data, not with some test data you're hoping is close enough to real. It's tested with real data of real users, right? And then on all stages, you can ramp along to test the scale. How well is it handling when we're these various stages? How well is it handling the dual writes? Is the new infrastructure getting the new writes without dropping anything? How well is the dark reads working? Is that working as expected? And then when that's all good, you transition, right? So a much smoother way to do things, more of a regular working hours way of doing things, and less stress. So that covers mindset and release strategies. Now I want to talk about data science, and you might say, well, data science, what does that have to do with releases? Well, you do a release, and if you're doing what this release technique I just described as progressive delivery, right, which is you roll out a bit at a time and you see how it's going. Well, how do you see how it's going? Do you see how it's going by looking at your regular charts and graphs? Do you see how it's going by looking at the logs? It can be a lot to look at, and frankly, again, we want to get away from fire drills and begging favors from people, and how do I make things just, how do I build in the ability to be aware of what's happening? So that's what we're going to talk about data science. So does it matter how you measure? Can we just change things and watch and see what happens. And the problem is that when you move to this kind of incremental way, or this progressive way of rolling things out, your data is different, right? Now, we're used to doing a release and looking for like a big spike in a graph that says, oh, we just did a release, did anything move quickly? And here's an example of that, which is we were looking at our own dashboards, and all of a sudden we saw these huge spikes right about the time we had done a release. And the team started scrambling around trying to figure out what's the root cause, what's causing this, where's the issue? And we'll come back to this, but this wasn't what it seemed at the time. So I'll back to this in just a sec. Let's look at another example though, which is here we're using progressive delivery. So we've actually rolled out a release, and you see where when the feature was released to 100%, there's a spike. So that's that traditional stair step, oh, something's wrong, we just broke something. But this is what happened at the 5% rollout. So we rolled it out to a small subset to limit the blast radius, to be careful and to observe. And guess what? There's just not enough data in your traditional graphs to notice those changes when you're only running it through 5 or 10% of your population, right? It's just the same as the rest of the graph. It's kind of lost in the noise, right? So that is why we want to actually figure out, how can I figure out what's causing what? And along those lines, it's a good thing to remember that correlation is not causation. And I'm going to show a slightly absurd example here, which is ice cream sales and shark attacks on the same graph. And it turns out they both spike in the summer, but you don't need to stop selling ice cream to stop the shark attacks. It's not going to make any difference, right? So I want to get back to that example I showed, which was that there are all those spikes in the graph. And what happened there wasn't the release. It was a coincidence that a customer of ours was undergoing a distributed denial of service attack. So we didn't know that at the time because the way we were looking at the data was just we were looking at these charts and graphs, right? And that's one of the reasons why we've evolved what we do, so that you can actually use science to solve these mysteries for you instead of a big, huge fire drill. Right? So getting back to, does it matter how you measure? The problem with your release and watching the metrics is that everything else in the world is changing at the same time, right? There could be other product changes. There could be marketing doing things. There could be a global pandemic like we're facing right now, or it could just be nice weather, right? All these things can affect your metrics because people will behave differently. The system will behave differently, right? So we need some way of separating the things we changed from everything else. And science gives us a very straightforward way to do that, which is if I run a controlled experiment, I basically split the population in half, and I only do the new thing for half of that population. But the entire population is getting all the other influences. So 100% of the users are having those outside influences, the weather, the marketing campaigns, etc. But half of them have the change I just made, and the other half don't have the change I just made, right? So the control and the treatment, right? And that is really where we unlock some amazing power, because this is not a new idea, a controlled experiment, right? But if we can do this in our regular release process without a lot of extra work, that's where we're going. So just a little bit about how that works, right? So there are steps to do when you're doing this, which is that all the data points are coming in from all the users that are going through your software, the old and the new versions, right? And you need to do attribution, which is to say, for each of those data points I'm getting, which ones are coming from users that are on the control and which ones are from the users that are on the treatment, or sort of the status quo or the new thing. And then I need to be able to calculate distributions of these different populations. And you can see in this graph, there's the bluish green ones and there's the orangish ones, and they're offset, which is great, which tells me I'm probably going to find something meaningful. And then we do the analysis. And here we're using statistical techniques to actually calculate the difference between the experiences and make sure they're not just random variation. Because there's going to be a little bit of noise and change between the groups anyway, but if they're significantly different from each other, logically, if these curves are far enough apart from each other, then I can say, yes, there's really a difference between the status quo and the not status quo. And this could be a good difference or a bad difference. This could be they're doing the thing you wanted, or this could be there's more errors or there's other things happening, right? So most of us are lucky enough to work in an environment where we have some aspects of modern software tooling to count on, right? And most modern dashboarding tools allow you to tag data for segmentation. So you could literally tag data for, this is the people going through this experience, is the people going through that experience, the people with the status quo, the people not. So you theoretically could perform an experiment just having feature flags and some way of tagging the data, right? Likewise, if you already have a business intelligence database, a data lake that you're putting all your data into, you could push in which feature flag did each person have on or off, and what did they do, and you could do a lot of calculation in your data warehouse and figure out how's it going, right? Now, it turns out that the problem with those first two methods is they're both really ad hoc, and they're both kind of very dependent on human effort. And they're not very repeatable, and so they require a lot of talent, and there's a choke point because only so many people are available to do so much work, right? Which is why a lot of companies have been building or buying an experimentation platform. The idea behind an experimentation platform is you set things up in advance, it consumes data, and it gives you answers as you go. So instead of you having to post-process the data or poke around and look for things, you actually get conclusions presented to you as the data flows in, right? So that's where we're going next, which is a release platform for adaptability. And the idea is, how do I automate this? How do I make this something that's just happens as part of the way we normally roll out software? So I want to talk about the anatomy of the system. So we talked about feature flagging earlier, and that's targeting, which is how do I control who gets what experience? And at a really simple level, that's initially I want to make sure only my developers and my testers get this, even though it's in production. And then I might want to roll it out to my own employees, maybe to beta testers, maybe to early adopters, maybe to free users versus paid, maybe to enterprise customers who've paid extra to get an early peek at things, whatever. I want to be able to target who gets what. And then I need to have tracking sensors that actually can capture what happens out there and absorb that data, right? So it says tracking sensors, but it's also really the tracking ingest. How do I bring in the data in a way that I can make sense of it? And then I need a statistical engine. It's not enough just to have a data lake with a lot of data in it. I need a statistical engine that knows how to calculate those distributions, those attributions and distributions on the fly all the time, 24/7, and that's what a statistical engine is. And then management console. You might wonder, well, wait, I kind of get the other bits, but management console, what does that have to do with it? Well, in order for all the teams to be able to use this and for them to be able to use it without begging favors from a wizard who sits in a dark cube somewhere, everything needs to be accessible in a way that, whether it's an API or a UI, there needs to be a very straightforward way people can get their hands on all of the data without having to ask somebody else for the data. It needs to be self-serve, and it needs to be easily understood by everybody, not just by a special data scientist, right? So targeting system. Targeting needs to be fast. It can never be in the way of your system. And it has this paradox, which it needs to be able to be random and sticky. So if I'm trying to split my population into 50% going this way and 50% going that way, I want to avoid bias. And so I want to truly randomly assign these populations. But I don't want those populations to be intermixing. I don't want somebody to go through this path on the first session and this path on the second session. So I need those assignments to be sticky, right? And I need the whole system to be reliable. It has to be designed that if anything ever goes wrong, the system just marches on. The users are never impacted, right? So you have to be very savvy about how do you make it never a single point of failure. So a targeting system, really, the idea is I've got a feature, I've got some new code I'm exposing, and I've got some traffic key, which is a user ID or an account number or something that's unique to that user or that user's business. And I want to take those two inputs and I want to reliably assign them to an experience, and I want to store that assignment so that I can make sense of it later for attribution, right? Now, we talked earlier about it being both random and sticky. And the way we do that really is you just take whatever that unique key is for the user and you run it through a hash, and the input for the hash is actually the unique ID of the feature or the code change that's happening, right? Those two will always come out with the same value. And because hashes distribute over modern hashes actually give you a fairly even distribution, and so you can actually calculate against this hash and come up with a number between 0 and 99. So you mod 100 it, you get put them in a bucket between 0 and 99. Now each user lives in a bucket between 0 and 99. And as I turn the dial up and down for what percentage of the users I want to have in the exposure, they will go in and out strictly by my control, not because they randomly get dropped into a different bucket each time they come, right? So it's random to get the assignment of the bucket, but sticky. That bucket stays the same for that feature for that user. So telemetry, we talked about sort of how do I have sensors. So telemetry just means I want to be able to track something that happens either in the user behavior or in the system behavior, and I want to be able to track that with the same key that identified the user when I decided which way to send them, right? And if you already have telemetry in your system, you really just have to put a wrapper around that to send a copy into your experimentation platform, right? And if you have like a BI database we talked about earlier, if you already have that, you just literally can go pull it from the warehouse along with the data about who went which way in an experiment and put it together that way, right? So telemetry is about bringing in the data and aligning it with the users. And then we go through those steps we talked about, the statistical engine, which will actually make sense of the data. So it's kind of, I call that automated sense making. And we build the distributions, we calculate the difference between the distributions. And that is how so this looks really familiar to when I was talking about data science, but in this case, there's not a team of data scientists madly working away at ad hoc queries. This is something that's happening all the time, right? And then there's that management console we were talking about, which how do I make sure that this is all just accessible, right? At Split, we built a system specifically to do this. We have friends who've built their own. We are still friends with them. We all learn from each other, but not everybody can afford the time and the effort to build their own experimentation platform and detract themselves from their main purpose of building software, right? Sometimes I talk about whether do you want to build the truck or do you want to deliver something with it, right? And so because there's more people that need to deliver things and don't have a giant team to build an experimentation platform, Split built a platform that you can just subscribe to, right? And we are pretty proud of the statistics we've captured about killing the release night. People who use our solution, literally, they're not working as many nights and weekends to do the changes they do. The changes are done almost exclusively during working hours, and there's even like a little break for lunch, right? And they're also automating their delivery with data. They do rollouts using data to decide what to do, not people trying to keep an eye on everything. They get alerts saying, wow, something's going wrong, and within minutes they've reversed their rollout, right? And the ones who are sort of furthest along on this maturity curve see every feature as an experiment. They literally will roll out a feature change and they want to know, did it make a difference or not? And they want to have hard data for that, not just people's opinions. So I know that was a lot of content, but my point was this approach is something that the really large, fast-moving teams were using to be widely adaptable before the current pandemic happened. And as we all try to figure out, well, what do we do now that the pandemic is here? And we have to work sometimes with smaller teams and almost certainly with more distributed teams. We need to actually make the process smarter. We can't just work harder, right? So let's move to the live Q&A. And I'm looking forward to having a conversation about this.